right, so we just did really basic inequalities, right? Now we're going to move on to solving inequalities. And when you think about that, what that means, remember when we solve equations, we're trying to get like x equals a number, right? Same thing, we're trying to get x is less than, or, you know, greater than, whatever it is, a number. So basically what I did in the previous video was these were all solved inequalities, and what I'm doing is I'm graphing the solution. Okay, so now we're gonna get to like, what if we have, you know, something like this, and I want to get it down into like this kind of form, right? I want to solve it, and then I'll know the solution, right? I know all the possible values x can be to solve this inequality. Okay, so let's just do this really simple first, with just numbers. Okay, if we just have 7 and 9, 7 and 9, 7 is less than 9, right? Let's say I want to add 2 to it. All right, so I'll get 9. Just like an equation, if I want to keep this inequality the same, if I still want it to be less than, I need to do the same thing to both sides. Right? That way I keep the left side less than the right side. So essentially you transform just like an equation. So an equation is in order to keep both sides equal, right? You need to add the same thing to both sides. Same thing here. If I want to keep both sides at the same relationship to each other, where the left side is less than the right side, or greater than, you know, whatever it is, then I need to make sure I transform both sides the same. Right? So it's actually very simple to solve equations because it's just like solving inequalities because it's just like solving an equation, right? So let's say we have this inequality. Your goal, just like with solving an equation, is to get x alone on one side. Okay, so that means I want to get rid of this 7. So it'll cancel out here. This time I'm carrying down, instead of an equal sign, I'm carrying down a greater than sign, right? And then 6 minus 7 is -1. And then I just solve this inequality. So I solve for all the answers that x can be. So an equation, right, there's only one right answer. But now because we have an inequality, we have a whole bunch of right answers. There's a whole range, right? If we wanted to graph this, sometimes you'll have problems that say solve it and then graph it. And I've got my -1, open circle, right? Because it can't be -1, it's only greater than. And then I shade to the right. And you can check this. So if you want to check, you can just plug in any number. So I can plug in, let's check if x is equal to 0. Okay, 0 plus 7 greater than 6. I'm plugging it into the original equation. Is 7 greater than 6? Yes, it is. And you can check multiple. Let's just say that's 5. Is 12 greater than 6? Yes, it is. Right, so any number I pick on this shaded area, I can plug it in to the original inequality, and it should check out. Okay, so that's how I know I shaded the right area. And you can see x can be lots of different right answers. It could be negative. It could be a negative, decimal -0.5 or something. It can be 0. It can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to infinity, essentially. So there's a lot of right answers when it comes to inequalities. Okay, so I want to solve for x. Okay, so that means I need to get rid of this 5. So since I'm multiplying by 5, I can divide both sides by 5 because that'll leave me with 1, right? 1x, it's just x. Carry down my sign, just like in an equation. And then negative 30 divided by positive 5 gives me negative 6. Right, so my answer is x is greater than or equal to negative 6. And we can check this if you want. What's a number greater than negative 6? Negative 5. Right, so let's check that. 5 times negative 5. Negative 25. Is negative 25 less than negative 30? Yes, it is. You have to remember, right? In terms, I know it's tricky with negatives, but it's better. I'm less in debt if I only owe somebody $25 versus $30, right? So negative 25 is bigger than negative 30. Okay, sorry, I lost my example. Oh, there it is. But yeah, otherwise this is just like solving equations. So we'll just do a few and then we'll move on. There's one tricky thing, that's why, about solving inequalities. Okay, so this time we've got, we have variables on both sides. And so if you remember, when we have an equation, what we want to do is get rid of the variable on one side so that we can move it to just, because we can't have something like x equals x plus, something like this. We want to actually solve for x. Right, so that means we need to get rid of the x on one side. So I'm going to get rid of this x here. Okay. 2x minus x is just x. Okay. That one was 0, right? 0 minus 15 is just negative 15. Now I need to get rid of my 5. Negative 20. And that is my answer. Okay, so I won't do too many more examples because I think hopefully it's pretty straightforward because it's really just like solving an equation. You just do the same thing to both sides. The only difference is that now you have an inequality sign as opposed to an equal sign, right? And then now you have lots of right answers for x as opposed to 1.